Hi, this is Brian Fogarty, and this is a video for Chapter 7 of the book Quantitative Social Science Data with R, the second edition. So, in this video, we are going to take a brief look at what are known as frequency distributions. I know you hear distribution, you're like, but we've already really looked at them. It's just how basically looking at how observations are spread across the different values of our variables. So when we looked at the count, we did count, that was technically a frequency distribution. So it's really straightforward, but we use it to understand how the basic information in our variables is sort of the descriptive statistics, right? So like the things that describe our variables, hence the name. So we're just going to jump in and look at this real quickly. So I set up a new our markdown file, set my library path, set my working directory, and I have my new code chunk here. So we are going to use data in this example on Scottish life expectancy by council area. So we need to load the tidyverse package and also read Excel because it's a Excel file that we're going to be reading in. Okay. There we go. There we go. All right. So it's in. All right. So let's read this in. I'm going to save it as an object called LE for life expectancy, and then we use the read underscore XLSX, and then the name of the file, which again needs to be in the working directory, is Scottish underscore LE underscore council underscore 2018 underscore 2020. Oh man, I don't remember if I named it that, but that's kind of annoying. It just doesn't drop the underscores. So I like go in and resave it. All right. Okay, so we see that it read in. There's 32 observations and 3 variables up here in the environment window. Let's take a quick glimpse. Every time I see, should name it something different because when I see Le, I think like it's something related to France. Okay, so this is really simple. This is, so there's 32 rows, which are observations. Those are council areas of Scotland. And then it's the average life expectancy for females and males over those 3 years. So 2018, 19, and 20. So it's just the average. Real simple data. All right. One way to look at a frequency distribution is just to use the table function in R, which is it's part of base R. So let's just look real quickly here. So table and then female life expectancy. Okay, so what do we see? We see values that start with 78.28 and go to 83.96. There are no duplicates, meaning that each value here is unique. That's kind of annoying if we're trying to show this in a table. So what we might want to do in this situation is to round. Let's round this stuff. So we can create new versions of these variables that are rounded, okay? So we're going to do LE. We're just going to add these. We're not going to create a new data object. I'm going to use piping and then mutate. And we will round female. We're going to call this one female underscore RD equals, and then we're going to use the round function. I love it when functions, like their names, are exactly what they do. It's so nice. All right, so the round function is part of base R. So we first say, okay, what is the variable? So you can see with the yellow up there, it says X, that's the variable. Female, and then the digits is corresponding to how many decimal points. We want 0. We don't want any decimal points. And then we're going to do the exact same thing for male life expectancy. So round male and then 0. Okay, so I think that should work. I don't see any problems. Okay, so now let's just take a quick look again here. Glimpse LE. Yeah, so we see now that this is rounded. So if we look at the table again, LE, we're going to use female round. There we go. All right, so that's an easier way to look at data like this. Now, I mean, we wouldn't necessarily always want to do this, but if we're presenting it in a tabular form, it makes sense around it. If we're plotting it, we probably want to keep the original values because it gives us more variation. Okay, so besides from just these are just the raw observations, and you know, if we're discussing this and showing this to someone, people are not very good at figuring out sort of relative amounts. So, you know, one simple way is to show percentages, just convert it to percentages. And so there's different ways we could do this in R. One way that I like is to use the describe package, which is actually not describe, but it's the shortened version of it, and a function called freq, F-R-E-Q, not the other kind of freq. So we're going to do library, okay, descr. All right, so obviously I've installed this previously. So let's see. So I'm going to run that. All right, and we've got no problems with that coming in. And we're going to do freq. Okay, so you see it shows up here. So frequency table, LE, $ female RD, and then it automatically creates a plot, a bar plot, which we're going to talk about in the next chapter. Let's get rid of it. Let's just say I don't want that right now. So to get rid of it, we're going to do plot equals false. Okay, so now it shows us a little different, right? It kind of pivots it to show us, but also gives us the percentages. So it's a little bit easier to understand when we're looking at this, right? That so 25% of council areas life expectancy for females is 82 years. All right. What do you think it is for males? It's actually not. It's not a tricky question. Males generally have lower life expectancy for numerous reasons. Let's see. Oh yeah. Definitely. Okay, so what do we have? So we can round the percentage, right? So roughly 22% of council areas have male life expectancy of 78 years. Okay, so that's it for this video. We're just taking a quick look here at frequency tables, frequency distributions, which we sort of already looked at before when we use the table, before when we use count. There's other stuff we could do here. We could do like cumulative percentage. And some other things, but we're just going to leave it. We're going to leave it at that. All right. So thanks for watching. I'll see you next time.